Hey guys, today we're going to take a look at some sort of more complex questions involving permutations. Basically what we're going to do here is we're going to look at some questions that there's sort of some tricks to being able to solve so that you can use these little tricks in different questions. So the first one we've got is a scenario where we have to use different cases. Okay, so we have to break the question up into two possibilities. Okay, so the question is that we're going to find number of seating arrangements for 8 basketball players on a bench if either the one center or both of the 2 forwards must sit at the end where the coach always sits. So the two cases here are going to be that we either have the center sitting with the coach or we have the forward sitting with the coach. Now these two things can't happen at the same time, so this is where we're going to break it up into two cases. Okay, so the first case, so let's see. Okay, so the first case we're going to deal with, case 1, is going to be that the center is with the coach. So center is with the coach. Okay, so in this scenario, the first over here, we've got the coach, okay, and then we've got our 8 seats. So 1, 2, 3, 4, 5, 6, 7, 8. So in this scenario, the center is sitting right here with the coach. Okay, so then after that, we've just got these other 7 seats, which we're going to fill with the rest of the players. So there's just 7 seats, so we're just going to have 7 factorial, which is equal to 5,040. Okay? So that's case 1. Now the other thing that can happen is we could have the forward sitting with the coach. So case 2 is that the forwards are with the coach. Okay, so once again, we've got our coach, and then we've got our 8 seats. 1, 2, 3, 4, 5, 6, 7, 8. But this time we've got a forward sitting here and a forward sitting here. So we're going to lock them in place. And then we've just got 6 remaining seats to fill with the rest of the players. Okay, so that's just going to be 6 factorial. Now, the one thing that we have to remember, of course, is that we could switch the order of the forwards. We didn't say which one comes first. So for each of these scenarios, there's 2 possibilities. So we're going to have to multiply by 2. Okay, so this is the order of the forwards. Order of forwards. Okay. And so this will give us 1,440 more possibilities. Okay? So now that we've got that, so we've either got these 5,040 possibilities, or we're doing the scenario where we have the 1,440 possibilities. These things are independent. We can't have the center sitting there and the forward sitting there. So it's an or question. Either case 1 is happening or case 2 is happening. Okay, so what we're going to do is we're going to take the solutions. We're going to say, okay, well, we had the 5,040, and we're going to add it to the 1,440. Okay, so that's going to give us 6,480 possibilities. Okay, and that's it. All right, so let's move on to a different question with a different sort of trick to it. So the next thing that can happen sometimes is we could have a question where everybody's in a circle. Now the reason this is slightly more complicated is if I take just a simple circle here with 4 people, and I say there's one person there, 2, 3, 4. Okay, so there's my seating arrangement. if I take that same table with that same group of people, and I say, well, what if I put person number 4 there, person number 1 there, 2 there, and 3 there? You'll notice that I've just turned the table. This is the same as this. Okay? So these two scenarios are exactly the same scenario. We've just rotated the actual table. So this is not different. Okay? So what we're going to do is we're going to fix one person in place and move everyone else around them. Okay? So when in a circle, we'll fix one person in place. And move everyone else. Okay? And so what this does is this ensures that we're never dealing with the same situation more than one time. Okay? So in this particular question, there are 6 people sitting around this table. Okay, so let's just go in here and we'll say, all right, so here's our table. We've got 1, 2, 3, 4, 5, and 6. So we're going to take this first person right here and we're going to fix them in place. Okay? They're not allowed to move. Everybody else moves, they don't move. So what you'll see then is that there are, there are now 5 people moving. Okay? So there's 5 people moving. Okay? So that just means that we're going to have 5 factorial possibilities, which 5 factorial is just 120. So we're just going to have 120 different possibilities. Okay? And that's all there is to that. So these circle questions, they seem a lot harder than they really are. Once you just lock that one person in place, it just becomes a simple question of rearranging everybody. Okay? So, let's jump over to the next page. Okay, and so this next one's a fairly straightforward problem. But this is actually one that people will often make mistakes on. Okay, and I'll tell you why. So first of all, so the call letters of a Canadian television station must begin with the letter C. Okay, so the question is, how many different stations could we have if we use 3 letters? And then we'll do 4 letters after, but let's just start with 3 letters. So 3 letters. Okay, 3 letters. So we've got 1, 2, and 3. So the first one has to be a C. The other 2 can be anything. So there's one possibility for this first letter. Okay, for the next one, there are 26 letters to choose from, so we have 26 possibilities. The third one, there's nothing that says you can't repeat, and that's where people tend to make a mistake here. So there's actually 26 possibilities here as well. Often people will write 25 because they're used to using this sort of decreasing number, because that's what a lot of our other questions have been like, but there's nothing to prevent us from using the same letter more than once. So that's why it's going to be 26 both times. And so it's just 1 times 26 times 26, which actually gives you 676. Okay, so there's just 676 different stations. Okay, so the next possibility here is that we could use 4 letters. Okay, so if we have 4 letters, 1, 2, 3, 4. Again, that first one has to be a C. We've got 26 options for the second letter, 26 options for the third letter, and then 26 options for the fourth letter. So there's 1 for the first. So again, we just multiply them. Okay, and we'll get 17,576 different stations. Okay, and that's that. All right. So, problem number 4. We're going to rearrange the letters in the word success. So first of all, we're going to do it with no restrictions, which this is the same as what we did in lesson 1.3. So to begin with, we're going to say, well, there's 7 letters, so we're going to have 7 factorial on top. Let me zoom in so it's a little neater. Okay, so this is because there are 7 letters. Okay, and then we're going to divide by 2 factorial and 3 factorial, and this is because we had 2 C's and we had 3 S's. Okay, so we put that into our calculator and we'll just get 420 different arrangements. Okay. So what we're going to do to complicate this is we're actually going to take an idea from an earlier lesson and combine it. Okay, so we're going to do it where the 2 vowels must be together, but keep in mind we still have the 2 C's and the 3 S's. Okay, so first of all, we're going to treat the E and U as one letter. Okay, so we're going to treat them as one letter. So now, instead of having 7 letters, we're going to have 6 letters. So we'll have 6 factorial. We still have to divide by 2 factorial because of the C's. We still have to divide by 3 factorial because of the 6's. Now the only other thing we have to remember to do is we have to multiply by 2, and this is because of the order of the U and E. Okay, because we don't know whether the E comes first or the U comes first. Okay, so when we calculate that, it just works out to be 120 different arrangements. Okay, and that's that. So I'll see you next time.